In this video, we'll discuss characteristics of dynamic routing. Dynamic routing is the concept that instead of administratively programming each route into a router, as is in the case of static routing, what you would do is you would connect the routers to their networks, program the interfaces, assigning the appropriate IP addresses to the different interfaces on the router, and then what you would do is you'd load up a dynamic routing protocol. And this routing protocol is responsible for sharing the routing table information with other routers on the network. And the idea is that if every router is sharing its routes with all the other routers, then every router would build up all this knowledge of all the different pathways on the network itself. So it really reduces the administrative burden of managing routing tables. So that's what the purpose of dynamic routing is. So once you've enabled dynamic routing, the paths that a packet takes can be altered based off what we call changing conditions. Now, these changing conditions are things like, if router C goes down, then with dynamic routing enabled, all the other routers would know that that router is no longer available, so they wouldn't try to route any packets through that router. They would find some sort of alternate pathway to take. So that's one of the huge benefits to dynamic routing, whereas with static routing that wouldn't occur, right? The routers would basically use the static route that you programmed, whether the destination router was up or not. And that's a huge problem with static routing. So the routing tables are updated by what we call a dynamic routing protocol. And as an administrator that's going to use dynamic routing, that's one of the first things that you have to decide is which protocol do we use to implement dynamic routing. And there's many different routing protocols, each with their own advantages and disadvantages. But what's important about these routing protocols is they're responsible for sharing the routing table information with other routers, and those routers would create the routes within their own routing table, but also the routing protocol is also responsible for updating that routing information. So as we mentioned, as changes happen on the network, the routing protocol sends updates out to all the other routers saying, hey, there's a change to this pathway, apply this change. So that's kind of one of the benefits of dynamic routing. As I mentioned, there's a number of different routing protocols that are responsible for updating these routing tables dynamically. And the routing protocols are kind of divided into two major categories, into what they call the interior gateway protocols or exterior gateway protocols. Interior gateway protocols are protocols that are designed to work with inside your network environment. So a lot of corporations, large enterprises, they'll have all these routers spread across the company, creating these different networks and connecting these different networks for internal purposes. So you would load, if you wanted to use dynamic routing, you'd have to load a interior gateway protocol on those routers so that they share knowledge with one another internally of all the routes that exist. Examples of interior gateway routing protocols are RIP and OSPF. Those are two very common routing protocols. And then exterior gateway protocols are responsible for sharing that routing information outside your organization. So an example of a protocol that's an exterior gateway protocol is BGP. So some of the advantages to dynamic routing is it's suitable in many topologies, whether it be a small network or a larger network. You can leverage the benefits of dynamic routing, which is the fact that you wouldn't have to program each router manually yourself once you load up these dynamic routing protocols. So it really is independent of the network size itself. Also, with these dynamic routing protocols, they facilitate change on the network. So as there's changes being made to your network infrastructure, the protocols are communicating that out to the other routers itself. So the updates are automatically applied throughout the enterprise, and that's a huge advantage over static routing, where you would have to go and manually program each of the routers themselves. So you do get greater uptime for the users, and you do get greater network throughput. Some of the disadvantages is sometimes it could be complex to implement due to the nature of the routing protocols themselves. So some of the protocols have more configuration parameters that need to be configured than others. So that could add to the complexity. It is considered less secure in the sense that these routing updates are sent out via the protocol. And when a router receives that update, it applies the change. So what happens if a malicious person kind of gets access to the network environment and sends out malicious updates, right, to all the routers? That's definitely a concern as well. And resources that are being utilized by the routers in order to accommodate, this dynamic routing and the dynamic routing protocol. So it does use up, CPU power, it does use up memory, and also it does use up bandwidth, whereas static routing doesn't. So because the routers are sharing the routing information by sending updates across the network in packets, then that's utilizing some of your bandwidth. So that's definitely a disadvantage. So in this video, we discuss characteristics of dynamic routing.